Tonight's video is about congruent figures. Please add this to your math notebook. Originally rolled and twisted by hand, pretzels today are primarily manufactured in production lines. After the dough is mixed, automated machines stamp the dough in a consistent form. These forms are the same shape and size. Recall from Lesson 1 that congruent figures are the same shape and size. The automation of the production line process ensures that pretzels are congruent. One way to determine whether figures are congruent is to see whether one figure will fit exactly over the other. Our goal for this lesson is to identify congruent figures and use congruence to solve problems. You have one vocabulary word, and that's side, side, side. For triangles, if the corresponding sides are congruent, then the corresponding angles will be congruent. Remember, corresponding is in the same place. And then also make sure you add hypotenuse to the bottom of your vocab log, just underneath on the bottom somewhere. Write the word hypotenuse, and that is the longest side of a triangle. You are sent home with a copy of these pictures, so make sure you cut them out and put them in your math notebook. Example 1 is identify congruent figures in the real world. So example A is the checkerboard. And when you look at the checkerboard, is there any piece of this checkerboard that you could cut out and put on top of each other over and over and over again? You should have answered yes. The squares on the checkerboard are congruent, so we can write the squares. If we cut one square off and place it on top of all the other squares here, they will be congruent. Is there anything else that's congruent? How about the checkers themselves? Those circles, if you take one checker off and place it on every other checker, they're the same size and shape. So the checkers. All right, look at example B. We have a target here. Are any of the shapes congruent? The answer is no. If you take any of these rings off of each other, like out of the picture, and try to place them on another ring, because each ring is larger than the last, there's nothing that's congruent in this picture. If I take the rings off and try to lay them on top of each other, we're going to get the same picture. So, not congruent would be our answer. Not congruent. All right, example 2 is identifying congruent triangles, and I've given you a picture of this that I would also like you to cut out and put in your notebook. While you're working on that, I will read to you from the book, so just listen while you're working on that. If all the corresponding sides and angles of two polygons are congruent, then the polygons are congruent. For triangles, if the corresponding sides are congruent, then the angles will also be congruent. This is called the side, side, side rule. Because of this rule, when determining whether triangles are congruent, you only need to determine whether the sides are congruent. So taking that information, the side, 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 we're going to look at these two triangles here and determine whether or not the triangles are congruent. So here we have, and you've pasted this picture into your notebook already, we have length AB, which is 4. And then we also have length DE, which is 4. And they tell us that right here. Then I have length AC, which is 3, and length DF, which is 3. And our last length here is BC, which is 5, and EF, which is also 5. So each side has a congruent side. Side BA here is congruent to side ED, and then side AC is congruent to side DF, and finally we have BC is congruent to EF. So because of the side, side, side rule, triangle ABC is congruent to triangle DEF. If you flip one triangle over onto the other one, it will fit exactly on top. You should also have this picture and paragraph and the papers I gave you. Please cut it out and paste it into your notebook while I read. For polygons with more than 3 sides, it's not enough to compare the measures of their sides. For example, the corresponding sides of the figures below are both congruent, but the figures are not congruent. What this is saying is, even though the measures of these two shapes on the outside are the same, see we have 120 and 120, 70 and 70, that doesn't mean that the inside angles are going to be the same. If the inside angles aren't the same, here we have 90 degrees, and here we have 145 and 35. If they're not the same measure on the inside, these shapes cannot be congruent. I can't cut this shape out and paste it on top of this one. They won't match. If you know that two figures are congruent, you can find missing measures in a figure. Example 3 is using congruence to find unknown measures. The instructions for this are to determine the unknown measures in each set of congruent polygons. So they're telling us that these two shapes are congruent, so they have the same size and the same shape. So knowing that, we know that if the sides are the same, and we can tell this side is congruent to this side is congruent to this side is congruent to this side, and then our last side is also congruent. If we know that, we also know that the angle measures are going to be the same. So I'm looking for x. This is what I want to know. So what angle corresponds to x? If I look on my shape over here, 93 corresponds to x. So the unknown measure is 93 degrees. Example B is a little bit trickier. We know that the corresponding sides are congruent, so we're looking for not the angle measures this time, but an outside shape. So what would happen if I took this shape here and rotated it a little bit so that the point was facing upright? So now I have a shape that looks like this, or something like it. And I'm looking here for A, which corresponds to this side, on my shape is right here. So you're looking for a side that corresponds to the original, and sometimes you have to rotate your shape a little bit. But A would be 3 centimeters. Make sure your notes are complete through example 3, and we will work through some practice problems tomorrow.